Hello everyone, in the last session we have started the calculation of magnetic force and we have seen the two cases. First case we have seen where the velocity is perpendicular or anti-parallel to the magnetic force and we have find that the path is going to be a straight line. Second, which is very important case for the NEET point of view, and we have seen that when the velocity is going to be perpendicular to the magnetic field, then we have a two cases that can be possible. Okay, sorry, not a two cases. Basically we have seen only the one case. There is another case is also there in this case only, but we will see this later. But remember, whenever the velocity is perpendicular to the magnetic field, first we have seen is that there will be a circular motion. There is another case is also there within that, that is a semicircular motion, or some part of a circular can be take place. So let us understand that part and we will proceed our discussion with the illustration. So let us just start with our illustration. Okay, my question is, let us take the example. The example is very simple. Suppose we have a axis, x axis, y axis and z axis. We have a three axes are there. Okay, we have a three axis. Suppose this is my x axis, this is my x axis, or this is my, let me draw it first, then I will name it. Okay, these are the three axes. Clear? And suppose this is my x axis and this is my y axis and this is my z axis, and I have given that is my velocity is equal to v naught j cap, correct, and my magnetic field is equal to v naught I cap, that is in I direction. Okay, you have to tell me the position vector of the particle RT. You have to tell me the position vector of the particle. Remember that I am leaving the particle from the origin. Okay, like that. I am leaving the particle from the origin, and the particle have a charge q, mass m, okay, and the velocity v. These things are given. You have to tell me the position vector at a time t. Okay, position vector. This is called as a position vector. Okay, position vector at time t. That is my question. Can you tell me what is the answer for this? Just use your brain and tell me what is the answer for this. How will you calculate the position vector of this charged particle? First you have to tell me in which, how it is going to do the circle. See, the motion will be circular only. Why? Because the velocity is going to be perpendicular to the magnetic field, as you can see. Okay, so path is going to be a circular motion. Path is going to be a circle. Okay, clear. Which circle? Okay, my question is which circle? So if you can see properly, see, my velocity is in z direction and the magnetic field is in I direction. What is the formula? V cross B. So V cross B, so it is coming inside, means my my circle is it is in inside, correct? It is inside, means the force is going to be act inside, and there means the center will be here. But now you can see the velocity is in this direction, correct? Sorry, the velocity is in this direction. It is going to do, the force is going to act like this, so it is going to do a circle like this. Okay, so what is the plane of this circular motion? The plane of that circular motion, can you tell me what is going to be the plane? This plane is going to be, what is that plane? What is that plane? Particularly, can you tell me what is it? Is YZ plane? Yes or no? What is that plane? Is it a YZ plane? Is it a YZ plane? Alright, you can see properly. It is going to do the circle in this plane only. It is which type of plane? This is YZ plane, correct? So I can do one thing. This is my X, this is my C, this is my X, this is my Z, and I want YZ plane. So I will rotate this plane like this. So my X plane will go inside, this is my Z plane, and Y plane will be above. So that is I am going to do. Okay, so what I am going to do, I am just going to rotate it. Okay, just I am going to rotate it. Just for the simple calculation, I am going to just rotate it. How I am going to rotate, just see here. See, you can see now, this is going to be my Z, this is going to be my Y, and my X is now inside. Okay, okay, this you can see, this is you can see this is my x, okay, that is inside. Clear? This x is inside. So now you can see the velocity is in this direction. Which, what is the direction of velocity? See, the velocity we know it is in this direction, magnetic field is in this direction. So V cross B you will do. So V cross B, so it is force is going to be act in this. So it is going to do the circle. We have seen it is going to do the, sorry, let me write it. This is V naught and this is magnetic field which is in x direction. Sorry, there is no magnetic field in z. Sorry, the magnetic field in z direction. So if you do V cross B, it is going to be act in this direction. So the path will be like this. What I am trying to say, it is going to do the circle like this. Okay, so let me draw it little away so that I can draw it properly. Means you have to understand why I have drawn like this. So my circular motion will be something like this. Not coming perfectly, but I hope you are getting the point how the circular motion is going to be. Correct? It is something like this. Okay. It is going to be something circular motion like this. It is going to rotate like this in this plane. What is that plane? This is a YZ plane. Now in this plane, to tell me one thing, what is the x coordinate? I want to write at time t. If I talking about at time t, the particle will rotate an angle of omega t. Correct? Correct? Any doubt? In time t, the particle will rotate an angle of omega t. This is r. So what is this? This thing. This thing is going to be what? This thing will be going to be r sine omega t. Correct? What is this distance? Can you tell me this distance? This distance will be, see, total distance is r. Total we know this is r. This is going to be what? R sine theta, and this is r cos theta. So this distance will be r into 1 minus cos omega t. Correct? See, total distance is r. This distance is r cos theta. I want to know this distance. So r minus r cos theta. So it is r into 1 minus cos omega t, or cos theta or omega t, whatever you say. So these two are the coordinate. What? So it is in YZ plane. So what is my x coordinate? So how will you write my r of t? See, x coordinate, there is a no, as the motion is not there, so there is no x coordinate. First we have a y coordinate. The y coordinate will be r sine omega t in j cap. Okay. Then we have a z coordinate, but remember the z coordinate will be negative. Why? Because it is YZ plane, but z is negative. So it will be cos omega t into k cap. Okay. Now the thing is that what is r? R we know simply it is mb upon qb. And what is omega? Omega is simple qb by m. So just put this value, you will get the position vector r of t is what? R of t is simply equal to mb upon qb into sine of qb t by m into j cap minus mb, sorry, minus mb upon qb minus cos into qbt by m into k cap. Correct? So this is by r of t, which you have got. Clear? Any doubt is there? See, you have to simply know how the particle is going to take the path. Okay, how the particle is going to take the path. If you are able to understand that thing, then it is easy to write the position vector. It is not that much difficult task. You have to understand in which plane it is going to do the circle. Okay, clear? Okay, let me take one more example so that it will be more clear to you. Okay, let me take one more example. I hope you have understand how to solve this. So let me take one more example for you. So let us just you have to understand the geometry. It's nothing but a geometry only. Okay, not something very difficult thing. It's a simple geometry. Suppose this is my y, this is my x, and this one is z. Okay, and suppose the velocity defined as some v naught k cap, and magnetic field is some defined as some b naught j cap. Okay, I have just reversed this. Okay, now you tell me what is the position vector r of t. at time t? That is a simple question. You have to tell me. Okay, I give you just 30 seconds. Just try to solve it within 30 seconds. Then I am going to do the solution for this. How will you solve? I hope you have completed. Let us see this. First, we have to simply understand in which plane it is going to be rotated. See, simply it is given the velocity is in k cap, means the velocity vector is going to be like this, and magnetic field is given in this vector, correct? So what you have to do, v cross b. If I do v cross b, it is coming inside, correct? So that means the particle is going to rotate like this, correct? Again, the rotation is like this, but see, now the plane has been changed. Now the plane is not that plane, it is now xz plane. If it is now in xz plane, if you try to understand, it is now in xz plane, correct? Now if it is now in xz plane, what I can do, I can just rotate. See, this is my y, this is my x, so I can just rotate it like this, correct? So if I rotate it like this, what will happen, I will get one vector like this and one thing is like this, correct? This is y will go inside, so you can see this is my y, correct? And this is going to be my x and this is going to be my z. See, z is given as velocity v naught and there is a magnetic field in y direction, so v cross b is coming inside, so this will rotate like this. So it is same circle, but now the plane has been changed. If you have getting a point, only there is a change in the plane, other things are remain same, only the change in the plane, okay? Other things are remain same only, there is a no change in the other things are same only there is a change in the plane. And suppose this is a some center c and set some angle, you rotate at omega t. What you have to do, take perpendicular, again same thing. So I am directly writing the answer. See, this z cap z vector will be what, r cos theta, and what is r, you know what is theta, theta means omega t, omega you know, everything you know. Now just write the coordinate. First thing is y coordinate is 0. What is x coordinate? X coordinate will be minus r into 1 minus, or I am directly writing, let me directly write it. So this will be mb upon qb into 1 minus cos of qb by m into t. This is my x, y vector will be 0. There will be no y because it is in xz plane. And what is z? Z will be simply mb upon qb into this is sine of qb t by m, correct? This is my r of t and this is the answer for this question, okay? So within 30 seconds, this, if you understand, it's a very tough question, but if you understand, there is nothing so much tough, clear, very easy if you understand it, okay? This type of question generally came in the exam and a student think, oh, how I will write the answer. No need, if you understand, it's a very easy, okay, simple thing, clear? So I hope you understand by these two illustration. I hope you have understand about the circular motion, then when the velocity is perpendicular to the magnetic field, how the path of the particle is going to be. I hope you have understand till here, clear? Now I am moving to the next case. It is a same case, but it is a same part, but it's a, you can say it's a slightly different thing, okay? It is the same case we are discussing, but it is a slightly different, slight difference will be there, okay? Let us see the what is the difference and let us analyze it, okay? Let us do the analysis of that. So suppose there is a boundary, okay? This is my boundary, and the thing is that the magnetic field is present only in the, only here in this region of the boundary, okay? There is no magnetic field in this region, okay? The magnetic field is only in this region. This complete region is full of magnetic field and the direction is inside. Clear? The direction is inside, okay? So let me ask you the question. Suppose the particle enter with a velocity v naught, okay, like this, and the angle is theta. First, you tell me what is the angle between the force and the velocity. That is my first question. What is the angle between the force and the velocity? What is the angle? Some people will say theta. Theta is not an angle between the force and the velocity. Velocity is like this, magnetic field is like this. The angle is what? 90 degree. Okay, it is magnetic field is inside, velocity is like this, angle is 90 degree. Here also, remember, this is here the velocity is again perpendicular to the magnetic field. That is the same case we are taking. We are talking about the case 2 only. Okay, case 2 only. We are discussing the case 2. It is a sub part. It is a sub part of this. You can say sub case. Okay, it is a sub case of that thing. We are discussing the same case. So let us understand this case. So in this case, see what is going to be happen, how the force is going to be act. If you are going to apply, that is V cross B, the force is like this, means the force is going to be, the force is going to be passed through this center will be somewhere here, because the force, because the center is the force is always passed through the center, so center will be something here. So the particle, how the particle is going to be moved, like the particle is going to be moved like this. Okay, let me draw it properly. Correct, it will be something like that. It haven't drawn properly, but it will be something like that only. Let me try to make it perfect. Okay, okay, this angle is theta, and it will come out with the same angle theta. Okay, and here if you will also see, it is going to pass through this center. Okay, so if it is like this, now you tell me, this is theta, this will be what? 90 minus theta. So this total angle is 90, so again this is going to be what? This is going to be what? This is theta, this is 90 minus theta, this is again equal to theta, that is 90, so it is 90 minus theta. This is 90 minus theta. This is also 90 minus theta. So what is the total angle? The total angle is how much? Pi minus 2 theta. So this case, for this case, they ask you the time period. How much time it is inside this region? What is the time? So simple, the time period will be, they will ask you the time period. So how will you tell the time period? How will you tell the time period? Simple, remembering one thing, that is that we know that angle is equal to what? Theta is equal to what? Omega t. Now from here we want to calculate omega. This is pi minus 2 theta divided by omega. Omega is what? QB to m. Okay, I haven't tell you one thing, just note it down. That is very important thing here, that this time period is independent of velocity. It doesn't depend upon the velocity. Okay, that is very important thing. Okay, just note it down. I will tell you why it is very much important. So this type of question they will ask you, for how much time it is inside this region. So the time is pi minus 2 theta into m divided by qb. If you make this theta equal to what? 0, then in that case the time will be pi m upon 2b. Correct? Any doubt? Any doubt is there? Completed? Any doubt? Okay, clear? Clear? Okay, you can take the same case with opposite direction also. What I am trying to say, like you can take the same case, but in spite of taking inside, you can take the magnetic field outside. Let the magnetic field outside. Okay, let the case where the magnetic field, this means the magnetic field is outside. Suppose I am same thing I am doing. I am sending a charged particle q, mass m, with a velocity like this. Okay, something like this, which is making an angle of theta with the horizontal. Okay, the velocity is v naught. So in this case, what is the direction of force? Remember, it is v cross b. Sorry, yeah, like v, you have to do v cross b. The force is coming downward, but let us take this is minus q. So it means v cross b, v cross b. The force is coming downward, but it will act upward because it is a negative charge. It is going to be rotate something like, it is not coming, this is negative charge, so force is going to be act like this. Here will be the center of this force. Okay, this is going to be the center of force. And what is the direction of force, if you ask? This is going to be the force. This is where it is going to make the circle. Clear? Any doubt till here? Okay, so the particle is going to be do like this. Now in this case, if suppose someone asks me to calculate the time period, how will you do the calculation for the time period? Simple case. Again, this angle is theta. This angle is 90 minus theta. This is also 90. Total angle is 90 because it is making a tangent. So this is also equal to what? Sorry, this is equal to what? Same theta, 90 minus theta. Then this is theta, that is 90. So 90 minus theta. Here also 90 minus theta. Correct. This is also going to be theta. Correct. 90 minus theta, then it is equal to 90 minus theta, this is theta. Okay, so again here if you calculate the time period will be what? It will be again 2 pi minus theta into m upon qb second. Time, how much time it will be inside the magnet. It doesn't matter whether you are having a magnetic field outside or the inside, it doesn't going to be matter, but the path is going to be the same. You can see. Clear? Only the path is going to be the same. How we are calculating? Just we are seeing the direction. Okay, just you have to see the direction and you can calculate easily. There is no problem with this. Clear? Any doubt? Clear? Now the last case, let us see the last case. What is the last case we can make? Last sub case. Okay, another sub case we can take what? Another sub case we can take, suppose we confined some reason. Okay, suppose we confined some reason, and in this reason suppose the magnetic field is inside. You can take outside also and do the things, only the direction of force will be changed, but yeah, the concept is same only. Okay, I am just telling for the insides, outside you can do the same. Okay, now the thing is that suppose the particle is sent with a velocity. Suppose there is a one particle which has been sent from the velocity of q, m and velocity v naught. Okay, this has been sent, and suppose this distance is given as t. Now I am not giving you the condition, any condition, but there two things can be possible. One case is what? This particle will go and it will make a half semicircle and come out. That it is possible only when this t is equal to r. Correct? This t is equal to or greater than r. Second case is what possible? This particle will go like this and come across, out like this. Correct? That is the two cases is possible. See, one case previous case we have seen. If you remember the first case is what? See, two cases, suppose the particle is coming like this, two cases are possible. One case is like it will make a circle and come out. That is the first case. Hemicircle or semicircle and come out. That is possible only when the distance is equal, t is equal to or greater than r. But what is the case when t is less than r? Then in that case, what will be the path? It is obvious that it is not able to make the semicircle also. So the path will be something like this, correct? Sorry, I deflected it before it reached the, it will be deflected from here now. As it reach, it get deflected. Why I have deflected in this direction? What is the reason, sir? Sir, if you see properly, my velocity is like this. V cross B, the force is going to be act in this direction. So at this point, force is going to, and suppose the center is here. Okay, suppose the center is here. Now the one more thing, suppose this angle is alpha, correct? If this is alpha, I will put a one perpendicular up to here and here. Now you tell me, if this is alpha, this is 90 minus alpha, this is alpha, this is what? Alpha, so this will be also alpha, correct? This is alpha, then this will be also alpha, correct? Any doubt till here? Okay. Okay, this is alpha. Now this is alpha. Can you tell me what is the condition for basically how, now if you write sine alpha, okay, sine alpha is what? See, P by H, this is radius, okay, so P is this distance, T upon R, that is MV into QB. So from here you get alpha is equal to what? Sine inverse of T QB upon MV, correct? So this is what they will ask you, the angle of deviation. This is called as an angle of deviation. Okay, angle of, these are the small questions basically which has been asked in either in NEET, JEE or JEE Advanced. These are the types of question they have asked. Okay, this is the very famous question. These are the basically from SC Verma only. So these are the different cases which can be possible within the second case. So we have discussed the second case completely. These are the sub cases. We have seen the how to find position vector, and we have seen some example. Then we have seen the case, within the case 2 we have seen the two sub cases. That is first case, this that is a previous case of one case we have seen, and the second this case we have seen. Okay, so I hope you have understand this case, these cases. In the next session we will see the another case and we will continue this discussion. Till then, if you have liked this session, please like it, share it and subscribe it. Have a nice day. Thank you.